Assalamualaikum and very good evening to my lecturer and to everyone. Okay, today we went to discuss about the tutorial 3 for the basic physical. Okay, Yana, I start for the question number 3. Yana, what is the answer for the question number 3? Can you give me the best answer?
Okay, let me see. The speed of sound in air is a function of which one of the following? A is a wavelength, B is a frequency, C is a temperature, and D is the amplitude. So, first of all, I'm going to answer this question. The answer is C, is a temperature. So, I'm going to explain this is why the answer is C. This is because temperature is also a condition that affects the speed of sound. Heat, like sound, is a form of a kinetic energy. Molecule at a higher temperature gain more energy, thus they can vibrate faster. Since the molecule vibrate faster, sound wave can travel more quickly. So for the conclusion, I will give in that the higher the temperature, the higher the speed of the sound in air. So that is the answer for your question. Thank you. So Amirah, I have a question in my head. It is about question number 4. What is comparing the speed of sound in liquid, gases, and solid? The speed of sound is usually lowest in blank and the highest in blank. So can you give me the answer?
Okay. For the answer, question number 4 is I choose D, gases and solid. For the explanation for this answer, the speed of sound depends on the electricity and density of the medium which is traveling. The lower the density, the faster the sound travel in a medium. So the answer for this question is D, which is the speed of the sound is lower in gases and highest in solid. Okay, thank you. Okay, we go to the question 11. Yana, for the question 11, I have difficult to solve. Can you show me how this question to solve?
Of course. So the question number 11, the question is, a sonic bow is tethered to the ocean floor and emits an infrasonic pulse of sound. The period of this sound is 71 meters square. Determine the wavelength of the sound. The speed of sound in seawater is 1522 meters per second. So, this is the calculation I already write down. So, okay, this one. The question for this is determine the wavelength of the sound. So we already know the period of the sound is 71 meters square, and the speed already given, which is 1522 meters square. So first of all, we need to know what is the speed, what is the formula of the speed. So formula of the speed is V equals to F times lambda, which is V is a speed, F is a frequency, and lambda is wavelength. Alright. So V is already given in this question is 1522 meters per second. Okay. We want to know what is the value of F. So we need to know. We need to find the F. So we put F in the formula of F, because we already know what is T. So we just include the just substitute T in this question. T is 71 meters square, and then the answer 1/71 is 0.014 Hertz for this frequency. So we just enter the frequency inside this formula, which is V equals to F lambda. Alright. We already know that speed is 1522 equals to 0.014, which is frequency, and what is lambda? Okay, we just substitute this one. 1522 over 0.014. So the answer for lambda is 1.09 times 10 to the power of 5 meter. Okay, Mira, I have one more question to ask, which is question number 18. The fundamental frequency of a vibrating system is 400 Hz. For each of the following system, give the three lowest frequency excluding the fundamental at which standing wave can occur. A. A string fixed at both ends. B. A cylindrical pipe with both ends open. And C. A cylindrical pipe with only one end open. Can you please explain to me and show the calculation if you need it?
Okay. Now I will show to how to solve the question for the 18. Okay. The question of 18, we know that for the fundamental frequency of a vibrating system is 400 Hz. For each of the following system, give the three lowest frequencies including the fundamental at which standing wave can occur. Okay, now we solve the A. A string fixed at both ends. This means for this question, for the at both end, for the formula for this question is Fn equal N times Fv. Okay. Now Fn, we use N is 2, 3, 4 because for this question it went 3 lowest frequency, so you can use for the 3 lowest frequency, you can choose any number. So I choose for N is 2, 3 and 4. So for the first I choose F2. Okay. Oh, we put F2 for this. F2 when N is 2. Fv from this question, fundamental frequency is 400. For Fv is 400 Hz. Okay. Then we solve this question. We got F2 equal to 800 Hz. For the second lowest frequency, we choose F3. So Fn is Fn is 3. When N is 3 and Fv is 400, for the answer is 1200 Hz. And the third lowest frequency, we use F4. When N 4, Fv is 400, so the answer is 1600 Hz. Okay, now we go to the second question is B. A cylindrical pipe with both ends open. This the same the A because these are both ends open, just like this. Let both open. So just like same for the A, just use that formula Fn equal to N Fb. When N, we choose 3 lowest. For this I choose 2, 3 and 4. So just like the for the question A, F2, just substitute 2 is 2, that is 400 for the Fb, and that's answer is 800 Hz. And for the F3, just the same, 3 times the F3 equal to N is 3 and Fv is 400. For the that's answer is 1200 Hz. And the F4, we just same like N is 4 and Fv is 400. For the answer is 1600 Hz. Okay, now we go to the last question is C. A cylindrical pipe with only one end open. For this keyword, for the keyword from this question, we know that only one end open. Okay, for this question, let me just do this. Okay, oh sorry. Okay, for this question, only one end open. For this formula, just like same the A and B question, just use that formula because they want to find the lowest frequency. So for this formula, for this, and we change because this only one and open. For the only one and open, we use n is odd number. For this question, we use 3, 7, 5 because this is odd number. So F3 is 3. So n is 3 and FV is 400. Same. So the answer is 1200 Hertz. Okay, the second is F5. So n is 5. When n is 5 and FV is 400, for the question, for the answer is 2000 Hertz. Okay, for the last is we use F7. So n is 7 and FV is 400. So the answer is 2100 Hertz. So there is answer for the 18. The